Hi, my name is Shannon, and I'm a systems engineer on the partner engineering team. Today, I'll be walking you through the code lab on creating automations using the Home APIs on Android. In a previous video, we covered how to build an Android app using the Google Home APIs, how to use the Device and Structure APIs to obtain and control devices in the user's smart home, and how to use the Commissioning APIs to add Matter devices to the Google Home ecosystem. If you missed it or would like a refresher on the Google Home APIs, make sure you refer to the previous video. In today's video, we'll cover how to build automations using the Home APIs on Android, and use the Automation APIs to create, delete, and query a smart home automation. Alright, let's talk a little bit about what automations are. Automations are a set of if this, then that statements that can automate device state control based on selected factors. Automations are made up of three different types of components called nodes: starters, conditions, and actions. Starters define the initial conditions that activate the automation, such as a change to a trait value. An automation must have a starter. A condition is any additional constraint to evaluate after an automation has been triggered. The expression in a condition must evaluate to true in order for the actions of an automation to execute. An action is a command or a state update that is performed when all conditions have been met. These nodes work together to automate behaviors using smart home devices. For example, you can have an automation that dims the lights in a room when a switch is toggled when the TV in that room is turned on. In this example, the starter is that the switch in the room is toggled. The condition is that the TV on-off state is evaluated to be on, and the action is that the lights in the same room as the switch are dimmed. These nodes are evaluated by the automation engine in either a sequential or parallel fashion. A sequential flow contains nodes that execute in sequential order. These typically would be starter, then condition, and then action. A parallel flow may have multiple action nodes executing simultaneously, such as turning on multiple lights at the same time. Nodes following a parallel flow won't execute until all branches of the parallel flow finish. There are other types of nodes in the automation schema as well. You can learn more about them in the Automation API documentation on the Developer Center. Developers can combine different types of nodes to create complex automations, such as a sequential flow with a starter and condition that then leads to a parallel flow of 3 action nodes executing simultaneously, and then a final action node. Developers provide these nodes to the automation engine using a domain-specific language, otherwise known as DSL, created specifically for Google Home automations. In this example, the automation synchronizes 2 light bulbs. When device 1's on-off state changes to on, then device 2's on-off state is changed to on as well. Note that when you are working with automations, there are resource limits. For example, the maximum number of nodes per automation. For the latest information, scan the QR code to visit the Google Home Developer Center. So we can see that automations are a very useful tool to create automated capabilities in a smart home. However, you might not be interested in writing every detail of code for an automation. Instead, what if we can empower the user to configure the devices, commands, or parameters themselves? The end user, after all, knows which action needs to be triggered by which device. In the next section, we'll go over how to create an editor that allows a user to configure an automation. Let's begin with setting up our automation starters. First, open up Android Studio for our project and begin with a starter view model Kotlin file. Our starter node will need a device, trait, operation, and value. The device and trait can be selected from the objects returned by the device API, but the commands and parameters for each device need to be handled separately. The app defines a preset list of operations, and then for each supported trait, a list of supported operations. In a similar manner, the sample app keeps track of values assignable to traits and a mapping between the values defined by the app and those defined by the APIs. The app then displays a set of view elements that users can use to select the required fields. For the next steps, open up the starter view file. Locate the to-do block 4.1.1, where all starter devices will be rendered in a drop-down menu. Next, render all the traits of the starter devices in to-do 4.1.2. Continuing on, render all operations and all the values of the selected trait in to-do 4.1.3 and 4.1.4, respectively. Finally, in to-do 4.1.5, store all starter view model variables into the draft. Now run the app and select a new automation. Here, we can see the new view for the automation starter we just implemented. Note that the sample app code only supports starters based on device traits. With our starters in place, next we'll implement our automation actions. The sample app uses the following entities to define the automation action nodes: device, trait, command, and value. Each device command action uses a command, but some actions will require a parameter value associated with it, such as the move to level function for brightness with a target percentage. The device and trait can be selected from the objects returned by the device API. The app comes with a predefined list of commands, and for each trait, a list of supported operations. For commands that take one or more parameters, there is also a variable. The API displays a set of view elements for users to select the required fields. Let's start with to-do block 4.2.1 in the Action View Kotlin file to render all action devices in a drop-down menu to set Action Device VM. Next, in to-do 4.2.2, render all traits of Action Device VM in a drop-down menu to set the action trait. In to-do 4.2.3, we're going to render all the available actions of the action trait to set the action. Then render the available values of trait action and store the value into action value level in to-do 4.2.4. Finally, for to-do 4.2.5, store all action view models variables in the draft automations action view model. Now rerun the app. With these changes in place, our new automation shows the dropdowns for the action. Now that you've learned how to create starters and actions, you are ready to create an automation draft and send it to the automation API. The draft automation preparation takes place in the draft view model class. Let's look at the getDraftAutomation function to learn more about how we structure the automation draft using the starter and action variables in the previous section. First, implement to-do 4.4.1 in the draft view model Kotlin file to set starter expressions according to trait type. Create the select expressions that create the automation graph for the start trait on/off. Next, go to block 4.4.2, implement the parallel expressions to create the automation graph for the selected action trait level control and the selected action move to level. The last step to completing an automation is to implement the getDraftAutomation function. In to-do block 4.4.3, create the automation by calling the home APIs and handling exceptions. Now run the app again and see the changes on your device. Now we can select a starter and action, name the automation, and then create it. Congratulations! You just created your first automation with the home APIs. Before we try out our automation, be aware that automations are validated when they're created. The API will return a value indicating whether or not an automation is valid and currently active. An invalid automation means that the server side was not able to parse your automation. In the case of an invalid automation, the isValid field will be set to false, indicating that the automation is invalid and inactive. Check the validation issues field for details. Now that you've made sure our automation is set as valid and active, you're ready to try out your automation. Automations can be executed in two ways. One way is to use a starter event. If the conditions match, a starter event triggers the action you set in the automation. The other is with a manual execution API call. For our example, we'll use a manual execution call. If a draft automation has defined a manual starter function, the automation can be manually executed. Let's try the code example in our sample app. On the automation view screen, tap the manual execute button. This will call the execute function, which runs your action command on the selected device. Now that you've confirmed the action command works through manual execution, it's time to see if it's also executing using the starter you defined. Go to the Devices tab and set Light 2's level control to 50%. Now try to trigger the automation using the starter device. Remember that we set Outlet 1's on/off trait as our starter. When we toggle Outlet 1 to on, we see the automation sets Light 2's level control trait to the original value 100%. And with that, you have successfully used the home APIs to create automations. If you want to learn more about the Automation API, scan the QR code to visit our Developer Center. The Home APIs include a dedicated API called the Discovery API that lets you query devices to find out what attributes and commands they support. Let's walk through the example in the sample app to see how this API discovers which commands are available. First, let's take a look at how to discover supported command candidates and how to create an automation based on discovered candidate nodes. In the sample app, we call the candidates function on the device to get a list of candidates. Possible candidates may be instances of the command candidate, the event candidate, or the trait attributes candidate. In Android Studio, open the Home App View Model Kotlin file and implement To-Do 5.1.1 to retrieve the candidate list and filter for the candidate type. In To-Do 5.1.2, set the support commands in the command map defined. Now that we are able to call the Discovery API, we'll look at how we can integrate this into our editor. The most common way to use discovered actions is to present them to a user. Just before the user selects the draft automation fields, the app can show them the list of discovered actions, and depending on the value they select, the app can pre-populate the action node in the automation draft. The candidates view file contains the view class that displays the discovered candidates. Implement To-Do block 5.2.1 to enable the candidate list items clickable function, which sets the selected draft VM to the selected candidate. If a draft automation is selected, the draft editor will be shown. Now let's try the Discovery API in our app. Tap on Light 2, move to Level. Great! Now we see the prompt to create a new automation based on the candidate's command. Now that you are familiar with automation creation in the sample app, you can integrate automations into your own app. Before we wrap up, let's go through some additional automation DSL examples. These illustrate some of the advanced capabilities you can achieve with the APIs. Previously, we noted that the sample app only supports device traits as starters. The Google Home APIs not only support device traits as starters, but any structure-based traits such as time. You can create an automation that has a time-based starter like the following. This code sample shows a scheduled time event as the starter, and when time is up, then we can perform an action. Another example of a more sophisticated automation is using the assistant broadcast as an action. The assistant broadcast trait is available either as a device-level trait in a speaker device, if the speaker supports it, or as a structure-level trait, because Google speakers and Android mobile devices can play assistant broadcasts. The example here shows an action where assistant broadcast announces that time is up. Then we have advanced operators, such as the delayFor and suppressFor functions. The delayFor function delays commands, and the suppressFor function can suppress an automation from being triggered by the same events within a given span of time. Let's look at an example. Here we see that the suppressFor function is used to ignore the starter for 1 minute after it was last triggered, and the delayFor function is used to create a 3-second delay between the intruder detected broadcasts. Finally, consider using AreaPresenceState, a structure-level trait that detects whether anyone is at home in your automation. In this example, the automation locks the doors when someone is at home after 10 p.m. And with that, we've built an automation in our Android app and completed an Android app using all the Google Home APIs. If you're interested in how to utilize the Google Home APIs to build an iOS app, make sure to check out our other videos. In the next video, we'll be covering technical tips and tricks as you continue your smart home journey. Congratulations again, and we can't wait to see what creative and advanced automations you'll unlock with the Google Home APIs for your users' smart homes. Good luck and happy coding!